Hey everyone, happy Monday. Very exciting topic and guest here today to explore challenges and opportunities of machine learning in business and enterprise. Eric, how are you?
Great, Evan. Thanks for having me on the show.
Well, thanks for being here. Your recent book, the AI Playbook, is so interesting, so timely, and I
Thank
can't
you.
wait to dive into it. Yes, the AI Playbook. We all need a playbook, but particularly in AI these days. We're going to talk a lot about the book and your background. Maybe introduce a little bit about yourself, your journey professionally, personally, and what you're up to lately.
Sure. Yeah, I've been in machine learning for more than 30 years. I was a professor at Columbia University, where I taught the graduate courses in machine learning and AI.
Mm.
And I've been an independent consultant for 20 years. I've been running the long running Machine Learning Week conference series, which comes first week of June in Phoenix. And I've co founded a startup. We're kind of still in stealth mode. Related to ensuring that machine learning actually delivers enterprise value.
Well, what an important topic, a big question mark there. So let's talk about the AI playbook a little bit. You have a six-step bizML process or practice. Maybe talk about the approach to that idea of a practice or a process, and your kind of unique perspective, having spent so much time looking at these things.
Sure. Well, it turns out that most new machine learning enterprise projects fail to achieve deployment. So the number crunching might be good. And indeed, the core
Hmm.
technology, this idea of learning from data to predict, that's established. It's got a proven track record, not just in research, but in actual deployment. It's just that in most of these cases, you don't actually get to that deployment. So the number crunching is sound. You're not necessarily getting operations to change. It requires change to achieve value. This is the technology you turn to improve pretty much any and all of your existing large scale operations, such as in targeting marketing, fraud detection, credit risk management, where to drill for oil, which satellite to investigate potentially running out of battery. All these large scale operations consist of decisions, and prediction is the holy grail for driving and improving those decisions. But if you do the number crunching and you garner from data the ability to predict, to put odds on these outcomes and behavior that matters so much for driving decisions, that's one thing. Actually making a change to the process, to the operation by way of those predictions, those probabilities, that's something else entirely. So bizML, which is the titular playbook of my book, the AI Playbook, and that's also the website for the book, bizml.com. Business
Mm.
practice for running machine learning projects is end-to-end practice where the first step is to plan for the last one, which is deployment. That use case, the value proposition is always defined in terms of two things: what's predicted and what's done about it. Who's going to buy? Market to them. Which transaction is likely to be fraud? Investigate or block the transaction. Which satellite's going to run out of battery? Investigate that satellite. Which object rolling off the assembly line is likely to have a fault? Which train wheel is likely to have a fault? Inspect it, right? So that what's predicted and what's done about it. And then the third component that all business stakeholders also need to get a grip on is how well it's predicted. How good is the model? How much potential business value would it deliver if you actually deployed it, if you start acting on those predictions? So that triplet, what's predicted, how well, and what's done about it, that's the kind of semi-technical knowledge that all business stakeholders need to get involved with, and in order to run a project successfully from end to end. And those are really the first three of six steps, not quite in that order, but establishing the exact deployment plan, the prediction goal, what's predicted, and then how well it's predicted. Those are the first three steps. And then the other three steps are the same steps that all data scientists are familiar with ever since, linear regression was used for targeting marketing and
Mm.
risk management in the 1960s, which is prepare the data, train the model, and then deploy it. So this sort of is a way to um, frame what it takes as an enterprise practice, regardless of exactly which technical solutions, which analytical methods you're going to use. This is the end-to-end practice where there must be deep collaboration between the quants and their client, the data scientist, and let's say the manager in charge of operations that are meant to be improved with a model. And that collaboration must be deep. And the business side people, the non-data scientists, must have ramped up on this semi-technical understanding. So if there's anything that my book, the AI Playbook, delivers beyond sort of outlining and trying to get everyone on the same page of the bizML practice, it's that exact semi-technical understanding.
Well, such an important point to talk about right up front. And so, what's your approach to bridging the gap between those technical aspects? I mean, I'm an electrical engineer, and still
Well,
much of this is above my pay grade, and those business leaders who have specific needs and reporting to shareholders and that kind of thing.
it's not above anybody's pay grade. This semi-technical understanding is not the rocket science. It's how to direct the rocket, how to use it. It's not
Mm.
how spark plugs and an engine work and how internal combustion operates, but how to drive a car. You need to be an expert. You need to understand momentum and friction and how the car operates and the rules of the road and mutual expectations of drivers. Same thing for running a machine learning project so that it successfully guides the deployment. So those three notions, what's predicted, how well, and what's done about it. Look, it's not a 1 hour lecture. It's a book's worth, but it's also not the
Mm.
rocket science. It's super accessible, understandable. This is the coolest technology. Why not learn about it? It's much more accessible, pertinent, relevant, and exciting than high school algebra. So let's make this more prevalent notion so that people can get concrete. So if you ask, what's my approach? My approach is convincing people to get their hands a little bit dirty in this respect. When the stakeholders' hands don't get dirty, their feet get cold. And that cold
Mm.
feet is what is the syndrome that repeatedly, routinely leads to these projects getting stalled before they actually deploy.
Oh, such an amazing point. Let's talk about one aspect of AI/ML, predictive analytics. It's having that crystal ball. It seems almost magical, but it's reality now. Can you share an example, case study, illustration of where predictive analytics had a major impact to a business?
Yeah, so these kinds of use cases, you could call them predictive analytics, and that's the title of my first book before this one. You could also call it predictive AI to differentiate from
Mm.
generative AI. And again, this is what you turn to for improving the efficiencies of existing large scale operations, because the
Mm.
holy grail for doing that is prediction. Now, we don't have a magic crystal ball, but what we do have to make it credible is the ability to predict better than guessing, which it turns out is generally more than sufficient to improve large scale operations. So I might find that this pocket of customers is 3 times more likely than average to buy. It may only be 3% likely, but that is such a big difference from the overall average. It turns out to have an improvement, an effect like that could improve the bottom line profit of marketing by a factor of more than 5. And sometimes you see factors of more than 11. So tipping the odds, business is a numbers game, tipping the odds a bit in your favor turns out to do wonders for, I mean, it's one of the last remaining points of differentiation of these large scale enterprise practices that are sort of become commoditized across organizations. Now, of course, in some cases, it can predict with extremely high confidence. Is there a traffic light in this picture detecting, the presence of diseases from radiology images?
Mm.
Both humans and both humans and computers can credibly do extremely well, and computers typically can do even better than humans, and that's great. But when you're trying to predict who's going to click, buy, lie, or die, like in the title of my first book, um, who's going to turn out to be a bad debtor, and which transaction is going to turn out to be fraudulent, the best we can hope for is predicting better than guessing, and that's a great thing to hope for, and that's what's delivered. So you asked for a specific example. My new book, my old book, Predictive Analytics, includes a central color table with 183 mini case studies. The new
Wow.
book focuses largely on 4 main examples: UPS, FICO, and 2 prominent .coms that were my own personal clients. So let me just quickly tell you how UPS actually predicts where there'll be deliveries tomorrow in order to
Very cool.
improve the efficiency of deliveries. By doing this, they improve that sort of last mile of delivery from or literally several miles from the shipping center to the endpoint destination. So a shipping center, might have 100 trucks and 1,000 pack, or several thousand packages, and it just has to decide overnight which package should be assigned to which truck, and then actually pack the trucks so they're ready for on-time departure in the morning, so that each truck has a relatively optimal route that could be driven, so that the time and gas consumed, won't be too great. So you're trying to improve that, and by predicting. So the problem is they have only partial information. There's a certain lack of information about all the package deliveries that'll be needed tomorrow, especially in the afternoon or early evening when they need to start making that planning and actually start loading the trucks. There's partial information. So they augment the packages they know, because they're physically in hand, by predicting where there will be deliveries tomorrow. Now they have a more complete likely view, and they can make a better, more optimal overall plan by doing that in combination with prescribing the actual driving routes. Because one thing to say, hey, this truck now has a potentially optimal driving route. It's another to say the human driver will actually find the right route. But by prescribing that, which they introduced some number of years ago in combination with this other system, UPS saves annually 185 million miles of driving, $350 million, 8 million gallons of fuel, and 185,000 metric tons of emissions.
Wow, that's extraordinary. What a great story. And
Yeah.
one that you can share too, which is unusual to get that sort of insight. Um, so tell us about an event, conference series that you founded, Machine Learning Week. How can people get involved? When, where is it? Virtual, in person? Tell us more.
Yeah, so Machine Learning Week, we've been running this event since 2009, and it's going to be co-located with a new first-time event, Generative AI Application Summit. And they're both on the two main conference days are June 6 and 7, and there are full-day workshops before that. So the whole thing is June 4 to 7 in Phoenix, Arizona. So keynote speakers include myself, Julian Simon, who's Chief Evangelist of Hugging Face, Jack Levis, who was formerly UPS, from whom I got the details. He's really the hero of that UPS story. He has an amazing story to tell. Morgan Vaughter, who's Global VP Data Analytics at Unilever, she actually provided a forward for my book, the AI Playbook. And Scott Zoldi, Chief Analytics Officer at FICO. And my book covers a case where FICO is the primary source of fraud detection for payment cards. So in addition to your credit score, they kind of, evaluate buying power by day and fight buying crime by night. This is extremely important for the integrity of commerce. Now, Scott Zoldi is actually presenting on responsible machine learning, responsible AI. But so it turns out the way I lined up the program for the Machine Learning Week sort of portion of the event aligns pretty well with the book that just came out last month, the AI Playbook. But in any case, there's tons of tracks. Unlike most of these more technical data science conferences, we also have a business track, operationalization, and bizML track. Again, that's the business practice for running machine learning projects so they successfully deploy. And then, of course, the whole 2-track generative AI conference. So you can think of Machine Learning Week as sort of the predictive AI conference. That's sort of the established use cases, older, but not old school. That's where most of the money is invested. That's where most of the proven gains are. And then, of course, up and coming generative AI, and we've got the tracks on that on the same days as well.
Fantastic. Well, it looks like an amazing event. Good luck with that.
Thank
And
you.
there is so much opportunity out there, but many transformational projects within enterprises fail for a variety of reasons. We've all seen those stories. What are the sort of common pitfalls that you've seen when facing machine learning projects, initiatives, and how can they be avoided? How do we avoid those roadblocks, those dead ends?
Yeah, I mean, this is a transformation project, so it does fall into a lot of the common pitfalls. But when we're talking about deploying a predictive model, changing operations with predictions, it's got its own landmines. And the overall syndrome is that everyone's so in love with the core technology. If you're using machine learning, you're using the best of technology. This is the leading edge practice. This is what it means to learn from the experience of a company, which has been encoded in data, and you can learn from it to predict who's going to click, buy, lie, or die. And those outcome predictions are exactly what you need to improve these large scale operations. So people erroneously sleep well at night thinking we're using the best technology, great, but we're kind of fetishizing it, right? And it's certainly hyped. So it's kind of like being more excited about the rocket science than the actual launch of the rocket, right? And that's probably true for a lot of rocket scientists, right? This stuff is so cool. Who cares if we launch the rocket? Maybe we'll launch next week, maybe never. I just love the rocket science part. And that's the syndrome, which leads to basically a lack of planning, a lack of collaborative planning between tech and biz, so that you're planning from the get-go exactly what it's going to take to gain buy-in, understanding, and change to operations. In other words, yeah, it's change management like any other, which is hard. But people need to reframe these projects and not just think of them. It's not a technology install, it's a consulting gig, because it's a change to the way the business is operating. It's not business as usual. It's more than just the number crunching. It's not just improving a new database system so the database runs more quickly. It's learning from data in a way that's then intended to actually actively change these large scale operations, millions of decisions a day. So that needs planning. It needs a change management discipline. People kind of forget that they need to plan for change because they're happy just doing the number crunching. So in a nutshell, that's the syndrome. That's the pitfall. Jump right into the number crunching before conducting a rigorous, holistic enterprise planning process.
Fascinating. So you kind of hinted at this, but you do talk about the interdisciplinary nature of AI and how it's so important to break down those
Yeah.
barriers and silos. How have you seen this done in a
Oh
particular
yeah.
entity or
Well,
organization? Well,
absolutely. The UPS story is a great success story.
mm,
Now, when they didn't quite plan for the change management as aggressively as needed, but they really did, relatively speaking. So that's one of the chapters kicks off with that story with UPS had deployed it, but it wasn't quite following through, and they weren't quite getting reaping the benefits from it. So then they had to kind of circle back and follow through more strongly on that swing. But overall, an amazing success story, and very unusual. This is not a big tech company.
mm,
This is and financial services has been doing credit scoring and targeting marketing forever, but this is an established enterprise more than 100 years old, set in its ways. That change management was took a lot of planning. Jack Levis, who ran that project, was really, really aggressive, and he had to really evangelize and get buy-in both up and below executives above him. And that's one story that I cover in the book. And then people on the actual loading dock and getting them to comply to the new system and stick with it. So yeah, I mean, it's about bringing those sides together. But I think that I would like to say, and I would hope that more data scientists in general would like to say, hey, business professional, yeah, you're not doing the number crunching. You're not operating the software that
mm.
learns from data, the machine learning tools. But look, there are these broad concepts, what's predicted, how well, and what's done about it, which is really interesting stuff, completely pertinent to what it means to run large scale operations in a modern way and more efficiently. This is what it means to apply science to business. Don't shy away from this. You don't have to change the spark plugs. You just need to learn what it means to actually drive a car.
Well said. I love that. So going back a bit, as a professor at Columbia and UVA Darden, what was your approach to teaching machine learning and AI to students of diverse backgrounds, diverse disciplines, not necessarily technologists, I assume, but all disciplines? What worked there?
Yeah, I was teaching machine learning AI at Columbia. That was more than 20 years ago, and that's in the computer science department.
Mm,
A year up until almost a year ago, I was a 1-year visiting analytics professor at UVA Darden School of Business. So this kind
mm,
of actually represents the arc of my career, where I was just like most data scientists. I fell in love with the technology. The idea of learning from data
mm.
is the coolest thing ever. that should be enough. And then, as I mentioned earlier, I've been a business consultant for more than 20 years. And now I'm at least as excited about the actual realization of business value, not just the generating of value, but the capturing of it, by way of getting these things deployed in a value-driven way and in a way that's meaningful for the enterprise, and aligns with enterprise goals, not just the sort of analytical, numerical goals the data scientists tend to focus on. So I would say that my approach to teaching, and I also have an online course available, machinelearning.courses, which kind of
Oh,
covers the
cool.
content of both my books plus more. But again, like the books, is accessible to newcomers and business professionals. I mean, my approach is to be like, look, you're trying to predict something in order to improve an individual decision repeatedly. This is what it means to sort of systematically act on probabilities. Nate Silver, the famous political poll aggregator, forecaster, statistician, and also sports prediction person, in his book, the Signal and the Noise, he talks about probabilistic thinking, but it's more than that. When we're talking about not just predicting, is the economy going to go up or down, or how many ice cream cones are we going to sell, it's which individual is likely to buy the ice cream cone. So it's probabilistic doing. It's systematically acting on probabilities over and over again, which again isn't rocket science. It's just sort of, it often comes down to a threshold. Hey, if this transaction is more than 30% likely to be fraudulent, then let's temporarily hold the transaction. It's an if-then statement and trying to decide where to draw the line. And sort of looking at that in a concrete, very specific way, and ensuring that the pertinent metrics align with organizational, it's arithmetic, but it's very particular arithmetic. It's not the rocket science, it's how to target the rocket. So it's something that everyone needs to ramp up on, and there's no reason not to. So maybe in a nutshell, my approach to sort of teaching and evangelizing the business practice is just to repeat that 5 times, as I've done already so far on your show. Maybe after we say it 5 times, hey, look, you don't have to be like, it's not calculus. It's not even algebra. It's just arithmetic. It's understanding some mechanics of what it means to repeatedly make these decisions based on probabilities. The word probability makes people fade out, but look, probability is just a number between 0 and 100 that says how likely is this given what we know. It's not a rocket science concept, and it's the only thing we have, because we don't have a magic crystal ball that tells us with extreme confidence what's going to happen. So the next best thing is these probabilities, and now they give us the opportunity to operate effectively over many decisions.
Brilliant. Well, you're such a great communicator, and you're on so many different media channels discussing AI to different audiences. What do you think about this hype cycle we're currently in? And how does this? What's next? I mean, we're in this. Some call it a bubble. It's certainly in every industry event I go to, and every conversation I have among family. Even AI is top of mind. Are we going to kind of settle down at some point, or has
No,
OpenAI and Google
yeah,
have we reached peak? I guess peak hype is the question.
no, not quite, but we will pretty soon. So before I kind
Okay.
of tell you my crazy take on the hype and what's true and what's not, let me just contextualize that. Like, most of what we've been talking about is really predictive, and that's what's valuable for potentially autonomously driving these large scale operations, such as which transaction to hold. Whereas generative gives you first drafts that generally need a human in the loop. So, um, so the hype these days, and most of the headlines are about generative, and it's extremely seemingly human-like, in a way I never thought I would see in my lifetime. It's incredible. I was in the natural language processing research group at Columbia for 6 years, and
Hmm.
it's all edge cases. It's sort of like, it doesn't scale. How do you get to sort of be able to work with human language in a general way? Well, to a certain degree, we've achieved that. To a certain level, it seems to be operating in a very general way with the notion of what a sentence or phrase or paragraph means. But there are still severe limits. So here's my take on the hype. We have to do the impossible. Well, almost impossible. You need to hold these two thoughts in your head at the same time. It's unprecedented. It's incredible what they did with learning from the data, which is the internet, right? All the written words, um, and images for image generation. And by the way, generative AI, generative is not doesn't refer to any particular technology. It's
Mm.
just the way machine learning is being used to generate content items such as writing, computer code, or images or video. And it's still the same concept of machine learning. It's just using it in a different way. Learn from data to predict what words, or on that level of detail, what word should come next while writing, or how
Mm.
should the computer change this image, this individual pixel as it's iteratively creating an image. So it's still the same underlying technology. So the two thoughts are, wow, this is incredible. It's so seemingly human-like. It's incredible what it can do. And yet at the same time, that does not necessarily mean it's approaching general human level capabilities. And that's underlying, or sometimes quite explicit, the overall narrative is that, hey, the computers are kind of coming alive. We're going to have artificial humans before we know it. People call it artificial general intelligence, a computer capable of any intellectual task. Intellectual there just to sort of differentiate it for robots, sort of just a technical difference. So let's call it what it is, artificial humans. They're coming alive like Frankenstein. I don't believe it. I don't buy it. I'm not saying it's necessarily impossible theoretically, eventually, but I do not think that what we have represents a concrete step towards AGI. I think that that's hype. It's the stated purpose of OpenAI. It's what most of the famous talking heads like Elon Musk and Bill Gates and Sam Altman and even more recently Mark Zuckerberg say, hey, we're going to have AGI. We're headed towards AGI. No. I think that that's a myth. I think that it's the novel that Mary Shelley would have written if she knew about algorithms, and that it's self-serving on some level, but lots of people truly believe it. But so those are the two things. It's like, hey, look, it's amazing and unprecedented, and yet still extremely limited. Ultimately, it's not autonomous. You need to review every draft that it writes before you let a customer read it.
So well said. What a great take. So looking forward beyond the hype, what are the real advancements, maybe practical advancements that you're most hopeful or optimistic about over the next year or two, and which industries might be most impacted by those advancements? Is it the finance example you gave, or transportation, logistics? Is it retail, healthcare? What should we think about?
Yeah, so I'll answer the question in terms of predictive and then generative. On the predictive side, it is just continuing to scale as it has now for 2 or 3 decades, depending on how you
Mm.
count. Um, the awareness, understanding, the infrastructure. It's also continuing to not succeed as well as the general belief, but that's catching up. And that's why I wrote the book. People are catching wind of, hey, look, it's not actually getting deployed. There's a lot of sort of half done projects, and then people have become very adept at sweeping those failures under the rug. But there's lots of successes. So even if it's a minority of cases, even if it's a third or 20% that are full of new projects that fully succeed, 20% of a lot is a lot. So there's a lot of successes, and that's going to continue to move upward, I think, as we get better at business understanding and business practice. And I'm evangelizing bizML as the brand to try to carry that forward. I think that the other thing is that right now the paradigm there is to create a business or a new enterprise line of business or what have you, and then you play catch up, kind of retrospective. You're like,
Mm.
okay, well now this is accruing a bunch of data, and typically the data in the big data movement and machine learning is found data. It's data that wasn't generated with the purpose of analysis, but it's just naturally an organic side effect of conducting business and transactions, right? And now let's see what we can learn from that. The problem is that the data is not organized in a way that's necessarily helpful without a bunch of rejiggering. And it may not have captured as much as we would like. It can be a bit of a messy project. instead of catch up, I think that enterprises and lines of businesses are going to be more and more planned and conceived of around that eventual use of the data and learning from it with machine learning. So sort of that narrative is going to be reversed. I think I see that happening over the next 5 or 10 years as a central theme. And then to answer your question in terms of generative, one of my mantras is it's not autonomous. It's not autonomous. That's not entirely true. For example, if it's a chatbot, as we know, it gets a lot of things wrong. It doesn't have general common sense reasoning on the level of a human expert, but it does have a lot of apparent ability to work with language that normally you would think of only a human doing. So it's a new thing. My thinking is that for a very well-scoped topic area, such as how to fix a laundry machine that a repair person might be on the field and they have a question about, or wine, the history of wine, how wine is made, and the different categories of wine, something I actually know nothing about. If you take a finite scope topic that we will, within several years, have generative AI chatbots that are helpful and that are dependable. They have reliability and that they know the right answer as often as you would expect the best human expert, and they don't tell you misinformation any more than you would expect from the best human expert. I don't think that we're going to achieve that anytime soon for the open topic areas like you would with a human, where you could talk about anything. But within these finite scopes, it'll have the advantage of sort of being able to work with casual human language, and will be an expert on a kind of contained topic area. So I think that's going to be fascinating. And then it is autonomous. Then you can unleash it directly on the customers.
Well, thanks for that. And this whole discussion has just been so insightful, so informative. I've ordered the book. Can't wait to get my hands on it. I encourage everyone out there, time to invest in yourself. Get the book and the AI Playbook, and follow Eric on all the social channels. That's where I discovered you, Eric. So your content is so illuminating. Thanks so
Thank
much,
you, Evan. Yeah, great being
and
on the
thanks
show.
everyone for watching. We'll see, this will be out on X and YouTube, Twitter, Facebook, LinkedIn, Instagram, and even TikTok. Imagine that. So,
Oh, I don't
all
think
right,
I've been
everyone.
on TikTok. All right.
You are now. So good
All
luck
right.
with that. Okay.
Awesome.
Thanks,
Thanks,
everyone.
Evan.
Take